Okay, now we are trying to look at the last structure question. The A part and B part are just like the old questions. Electrifying, calculating field strength, you can do them. Now the C part, an electron initially travels parallel to the plates along a line midway between the plates, as shown in figure 2.1. The speed of the electron is this much. For the electron between the plates, determine the magnitude and direction of its acceleration. So what we have is a situation like this, where there's an electron being an electron is coming in with 5 into 10 to the power 7. The separation of the plates is 1.5. It is entering the region midway, that is at 0.75 from the bottom or top. The length of the plates is 12 centimeters, and in the earlier part you have calculated the electric field strength. Now what is going to happen to this electron when it enters this region? When this electron enters this region, now this is the positive plate and this is the negative plate, so the field would be downward inside the plate. Okay, I'm just putting it outside to show you the direction, but they are saying that outside there's no field, so inside the field is downward. For a positive charge, electron is negative, so it is going to experience, once inside the field, the electron will once it comes into the field, it would experience an upward force. So there is an initial velocity and there is a force perpendicular to the direction of the initial velocity. So this is the projectile scenario. Initial velocity and a force perpendicular to that initial velocity. So it would follow a projectile path, a parabolic path. Here the force is upward, so it would follow a parabolic path like this. So it's going to follow a parabolic path. We don't know whether it's going to hit here or it's going to leave or it's going to hit somewhere in the front. We just know it's going to follow a parabolic path. So this distance, the horizontal distance of the plate is 12 centimeters and the remaining vertical distance is 0.75 centimeters. The entire thing is 1.5, so this half is 0.75. So if we look at the question number C, they're asking you to calculate the acceleration and the magnitude of its acceleration. The acceleration and its direction. The direction is going to be upward because the field is downward and it's going to be upward. Magnitude, to find the magnitude, you have to use F is equal to ma. Mass of an electron is in the data sheet, so you have to find the force. In the B part, you calculated the electric field strength, and that electric field strength is equal to 1.4 times 10 to the power 4 Newton per coulomb. This you calculated in the B part. So now you can the equation E is equal to F over Q. So F is equal to EQ. So if you use this in F is equal to ma, EQ is equal to ma. So 1.4 times 10 to the power 4, that is the electric field strength, times the charge of an electron is equal to the mass of an electron. The charge and mass, you can refer the data sheet in the exam paper, times This will give you an acceleration value of 2.5 times 10 to the power 15 meters per second minus 2. Okay. So if as far as the direction is concerned, it's better to show the direction using an arrow, because if you look here in the mark scheme, towards the positive plate or upwards is given full marks, but inside brackets they are asking you, they are also mentioning normal to the plate, that the acceleration is not like this, but like it's upward, but it's vertically upward. So perhaps in another paper they might expect that as well, so it's better to show the direction very clearly using an arrow, so there is no space for argument. Okay. The D part of the question, it says that use your answer in C to determine whether the electron will hit one of the plates or emerge from between the plates. So sorry, we are not yet done. So in the B part there is a second part. In the B part there's a second part where they are asking you to calculate the time for the electron to travel a horizontal distance equal to the length of the plates. So horizontally it is entering the region. Horizontally, if you look, it is entering that plate with the speed of 5 into 5.0 times 10 to the power 7 meters per second. Now horizontally there are no forces, but the only force is electric force, and that is vertical. Okay, in this case, guys, understand very clearly, in this case we are ignoring the effect of gravitational force. We are ignoring the effect of gravitational force. Strictly speaking, there is going to be not just the electric force vertically upward, there will also be the gravitational force vertically downward, but we can ignore this. Okay, and why I ignored it? Because if I haven't ignored it, it would have made the calculations a bit difficult, quite arduous. So I ignored it, but it's better that before you start doing the C part, where you're using the resultant force as the electric force, in the C part, in the beginning, you are using the electric force as the only force and hence the resultant force. It's better to make a note that mg is very, very, very less than F electric, hence mg is ignored. Okay, or else if you are adamant, you can take mg into consideration and can solve it. It will just make your life more difficult. But at the same time, please don't go ahead, even in the mark scheme they are not mentioning this, they are simply taking the only force to be the electric force, but you go ahead and mention this because that is the real explanation. So they're asking you to calculate the time. So there is an acceleration. This object is coming with the horizontal velocity. It has a certain acceleration upward, which we calculated to be 2.5 times 10 to the power 15 meters per second minus 2. But the question is to find the time taken to travel the horizontal distance. Horizontally, it is a constant velocity, so you can simply find that speed is equal to distance divided by time, and from that, using that equation, you can find the time taken. So the distance is 12 centimeters, the speed is 5 into 10 to the power 7, so 12 centimeters. So that gives you a time value of 2.4 times 10 to the power minus 9 seconds. So this is the time taken for the electron to travel the horizontal distance 12 centimeters. The D part of the question, they're asking you to use your answers in C to determine whether the electron will hit one of the plates or emerge from between the plates. So basically they are posing this question whether the electron is going to hit the plate or is going to emerge without being hit. Okay, whether it's going to hit here. They're not asking whether it's going to hit at the very end or before the end. They are asking simply whether will it hit or will it not hit or not hit. So we know that, and they're guiding you to use the answers in C. In C, we calculated acceleration, and in C we also calculated the time. Other than that, we know that initial velocity vertically, there is an initial velocity, but that initial velocity is horizontally. Vertically, the initial velocity is 0. Vertically, the final velocity, we are not concerned. Vertically, the distance is... Okay, so how we can do this is, we know the time, we know the acceleration. First, let's try and calculate what is the vertical distance traveled by the electron when it reaches the end of the length. When the electron comes here, where would it be vertically? Will it be, if the vertical distance is equal to 0.75, the vertical distance traveled by the electron when it reaches here is equal to 0.75, that means it will hit just at the end. If the vertical distance traveled by the electron when it reaches here is less than 0.75, that means it is still in mid-air, and that means it will emerge from the plates. Okay, listen carefully. If the vertical distance traveled by the electron when it reaches here is equal to 0.75 or more than 0.75, then it will hit. So if I write it, if S is greater than or equal to 0.75 centimeters, it implies hit. If S is less than 0.75 centimeters, it will imply that the electron will emerge. The vertical distance traveled when it comes here is less than 0.75, then it will still have some gap here to travel, so it will emerge. So basically the question is asking you to calculate the vertical distance. So we need an equation without V, so I'm applying S is equal to ut plus half at squared vertically upward. S is equal to u0 half 2.4 times 10 to the power 15 times 2.4 times 10 to the power minus 9 squared, and this gives you an S value equals to 0.71 centimeters. So the vertical distance traveled is 0.71, so that is less than 0.75 centimeters, which means the electron will emerge. And you can do it vice versa. You can find the time taken to travel the vertical distance 0.75. and if that time is greater than the time taken to travel the horizontal distance 12, then it will emerge. If that the time taken to travel the vertical distance 0.75 is less than the time taken to travel the horizontal distance 12, then it will hit. Okay, so you can use that condition as well. That answer is also there in this game.